Okay, good morning and good afternoon to all of you. Welcome to this product launch, expanding the SPOT Plus pyrometer family. My name is James Cross. I'm the head of industry management at Land, and I'm joined by Derek Stuart, our global product manager. So what do we have for you today? Quick background on Land for those that are new to us. We're going to run through the importance of wavelength as it relates to infrared pyrometers, a small recap on the SPOT Plus itself, the new instruments, the models that we're releasing today, the M390, the M3 to 5, and then a little bit of background on field of view before we talk about the SPOT Plus TMT conclusions, and then we do have time for questions at the end. We should be about 25 to 30 minutes on the product launch, and then we'll have time for a 15-minute Q&A at the end. If you can post your questions in the Q&A tab, we'll review those and answer as many as we can in the final 15 minutes. So think of your best questions, your hardest questions. We've heard a lot of them before, but we always get some new ones, and we'll do our best to answer those. So very briefly on Land, before I pass over to Derek, you'll see we're wearing a slightly refreshed logo, slightly refreshed brand. So we are Land. We're a business of AMETEK Inc. Land from Dronfield in Sheffield, where we're presenting from, has been innovating for over 75 years from the same location. We're a global leader in infrared industrial temperature measurement. We manufacture and really focus our strategy going forward on our pyrometers, on our line scanners, and on our thermal imaging systems. Temperature is in our DNA, and so is high performance in the harshest conditions. We support industries with product quality, with optimization, and with process efficiency in some of the highest temperature and some of the dustiest, dirtiest, loudest environments you can imagine. And we do that with a focus on hazardous areas. So that's IECEx, and we're an audited factory by an accredited facility. And we're also an ISO 17025 certified laboratory here in Dronfield and in other global service centers as well. So getting into the products, I'll hand over to Derek Stewart, our global product manager, and you'll hear from me on one of the product focuses and then again at the Q&A. So over to you, Derek.
Okay, thanks very much, James. Yeah, thanks for the introduction. I've been part of Land for nearly 35 years now, so I've been certainly around the business, and many of you joining us today have probably met me at a on site somewhere or at a trade show at some point. Anyways, what I'd like to do today is to start by giving you a bit of background on the SPOT Plus pyrometer series, because we've had those for quite some time. I'm going to start with talking about wavelength and temperature measurement, because that's really quite relevant to what we're going to be doing today, and especially the relationship between wavelength and temperature measurement. Here at Land, the graph that's on the slide there, showing the Planck function, is something that's very much part of our DNA. And what we're looking at here in this graph is the intensity of radiation emitted by a hot body at different temperatures. Starting at the top with 5,500 degrees Celsius, that's about the temperature of the surface of the sun. So what you've got there is the spectrum of the sun, going all the way down to ambient temperature at 20 Celsius and even to some cryogenic temperatures, minus 220 degrees C. And some key characteristics you'll note from, sorry, I should also explain the x-axis here is a logarithmic axis of wavelength, going from 0.2 microns, which is in the ultraviolet, through the area where the rainbow spectrum is shown, which is the visible spectrum, and going out through the near infrared, mid-infrared, and out into the long wave and far infrared. And the characteristics that I'd like you to note from these graphs are that as temperature increases, the area under the curve increases greatly, and that's the total amount of radiation emitted by the object. And also that the peak of the curve goes to shorter wavelengths as the temperature increases. Consequence of that is that if you're using infrared technology, an infrared pyrometer to measure temperature, you have to use it's best to use a short wavelength pyrometer to measure hot objects, things like steel from a rolling mill, hot slabs coming out of a reheat furnace, or the internal parts of a reformer furnace or a boiler. For those, you want to be using shortish wavelengths, and then as things come closer to ambient temperature, down to certainly below 500 degrees Celsius, there's very little intensity in the sort of 1 micron short near infrared wavelength. So we have to go to longer wavelengths to make those measurements. Up till now, our SPOT pyrometer or SPOT Plus pyrometer series has operated in the 1 micron to 2.5 micron, pretty much near infrared region, which is ideal for most metals applications, certainly for hot rolling, casting, continuous casting. That's absolutely ideal. But they've been limited in their low temperature capability, and there's some applications specifically where wavelengths out in the 3 to 5 micron region are needed. So now we can cover the full wavelength range from 1 to 5 microns, and the full temperature range up from 0 up to 3,500 degrees Celsius, or 122 to 632 Fahrenheit if you prefer. The key points about SPOT Plus, and something that we've really been working on in our product development, is that these are standalone temperature measurement systems, so that the all of the signal processing and outputs are generated in the pyrometer head. We don't need an external processor to do calculations, to do emissivity corrections and things of that sort. They're really quite clever. We call them smart pyrometers. They have LEDs for targeting. There's a built-in video camera, so you can see what you're looking at, both with the little display on the pyrometer head and remotely using our web server. We have a variety of ways of interacting with it, traditional 4 to 20 milliamp and discrete outputs, plus lots of interfaces for factory automation, Modbus TCP IP, REST API, Ethernet IP, and web server. So those are really aimed at slightly different markets, but each of them has its own niche, its own application, and they're all included in the instrument. If you want to experience the user interface, there's a neat little simulator that's available on the website, and there's a link there, or just go to the SPOT Plus page on the website and click through from there. We have a range of monochromatic single wavelength pyrometers that are used for fairly typical temperature measurement applications. And then we've got some specialist ones for more difficult and more unusual applications. One of the things we're very proud of here at Land is that we tend to focus on some of the more difficult temperature measurement applications. You know, we're not competing with pyrometers you can buy from Amazon for £50. So we've got ratio pyrometers. Those are dual wavelength devices that can measure down to 125 and up to 1800 degrees Celsius. Those are ideal where you may have an obscured view of the target or where the emissivity may be changing. Fiber optic models allow you to make measurements typically where the ambient temperature is too hot to actually place the electronics of the pyrometer in the position where you want to make the measurement. So the fiber optic head can be located somewhere up to 200 degrees Celsius, and then we keep the electronics a few meters away where it's a bit more cool and a bit more user friendly. And for the most difficult applications, things where emissivity changes with temperature, or where we have some very shiny objects like aluminium measurements, measurements in foundries, measurements of galvanized steel, we have application-specific pyrometers for those. James told you it's a product launch, so getting into the meat of the presentation now. What are our new models? What have we done to complete the SPOT range? Well, I think the key thing here is that we've introduced new mid-wave infrared models. So those allow us to make measurements at lower temperatures. They allow us to make measurements at different wavelengths where there's some neat characteristics, particularly at 3.9 microns, where there's some useful spectral gaps that we make use of. In these new models, we've really been focusing on reliability. We put a background temperature correction algorithm in all of the models. I'll talk a bit more about that later on. And having all the different interfaces, they really have functions for factory automation, and we put cybersecurity in there as well. Anything that can be networked, as I'm sure you are all aware of nowadays, can be hacked. So we put some security features in there to make it much more difficult to hack. Making it impossible is itself impossible, basically. Oh, and the last bullet point on the previous slide, we've got all of these available on short lead times. If they're not actually in stock at the factory here in Johnfield, then we can produce them within a very few weeks. So you don't have to wait months and months for these pyrometers. They're available very readily. This graph shows the wavelength coverage of the SPOT Plus range. If you look at the lower part, these are our older models, and they go up to about 2.5 microns in wavelength, going down to about 500 nanometers. The three new ones, two of them operate at 3.9 microns, and there's a broadband 3 to 5 micron pyrometer as well. So we're really completing our coverage of the infrared wavelengths that are useful for temperature measurement. And we broadened our temperature range so we can now go down to 0 degrees Celsius. We used to be limited to 50 at the extreme. We haven't gone any higher at the top end, but we really don't know of any applications above 3,500 degrees Celsius. That's really outside almost any normal industrial temperature requirement. So there's three new pyrometers that I want to talk about today. The first is the SPOT Plus M390. We actually gave this one a soft launch last year, so we have had a few of them out there and done a little bit of promotion on them. But really, it's part of the set of 3 that we've been working on. So we're wrapping it up in this launch today so that everybody knows about it. And we're describing the SPOT Plus M390 as the furnace pyrometer. That's because it's 3.9 micron wavelength is a spectral window in furnace applications. There is nothing in a typical furnace atmosphere that absorbs and emits at 3.9 microns. So it doesn't matter if you've got hot carbon dioxide, hot carbon monoxide, you've got visible flames there. To a pretty large extent, nothing interferes with the measurement at that wavelength. even if you've got some smoke, the longer wavelength will see through smoke much better than our short wavelength pyrometers. There are limits, but by and large, in a furnace atmosphere, the 3.9 micron wavelength works extremely well. It's got a very fast response time, 1 millisecond, which is much faster than any of our older mid-infrared pyrometers, which tended to be up in the 100 to 500 millisecond response time. So if something's happening fast in your process, you can see it. Measurement uncertainty up to 1100 Celsius, we've got 1% Kelvin, a little bit worse than that at the highest temperatures. And it's really intended for reheat furnaces and applications where you're looking at an object within a furnace that may be surrounded by flames and certainly by hot gases. And it's got a built-in background correction algorithm using an external input. All of the pyrometers I'm going to talk about today have got this algorithm, but it's particularly useful for the M390 because of its furnace application. If you look at the little image here, what we've got is two pyrometers. This is the M390, and it's looking at a slab or a bloom in a reheat furnace. In this application, what we've got is a piece typically of steel that is being brought up to temperature, so it's ready to go into a rolling mill. The input temperature for the mill has a great determination of how effectively the rolling goes, what the characteristics are of the strip that comes out of the mill. The problem is, if you're looking at an object that's cooler than its surroundings, as it will be typically in a furnace, the pyrometer is going to see the infrared radiation emitted from the surface of the slab or billet, which is great. That's what we're trying to measure. What's more difficult is it will also see the radiation emitted from the walls of the furnace, which reflect off the object, and that confuses our reading. Fortunately, the physics here is relatively easy to understand. The calculations are well known. So we have either a second pyrometer or potentially a thermocouple measuring the temperature of the furnace wall. We can take that as an output, input it into our M390, and then give you a true measurement of the billet that's in the furnace. So that's a really neat feature. We used to have a product called the FTS furnace temperature system that we discontinued a few years ago. We've had a lot of requests to bring that back. So effectively, that's what we've done with the M390. The M3 uses a broadband 3 to 5 micron wavelength, and that, as you will remember from my discussion of the Planck function, that longer wavelength allows us to measure cooler temperatures. So we're describing this as our low temperature pyrometer because it's got a measurement range all the way down to 0 degrees Celsius. It can measure 0 to 500 Celsius. So it's ideal for applications like heat treatment, the coiler at the end of a rolling mill, or some semiconductor applications where we're looking at moderate temperatures. Typically, you won't use a 3 to 5 micron pyrometer to measure things that are within the ambient temperature region. That's where your extremely cheap £50 from Amazon device will work. But if it's an object that can vary in temperature from just above freezing up to a few hundred degrees Celsius, that's where the accuracy and features of the M3 to 5 really come into their own. Again, it's got a fast response time, 10 milliseconds. And like the M390, the field of view is 30 to 1. Get that one. Typical application for an M3 to 5 is a cold rolling mill where temperatures tend to be in the 100 to 300 degrees Celsius. It's a low temperature process, and so we want to measure down close to ambient temperature. We've got two products that can measure in this region. The SPOT M390 can go down to 50 degrees Celsius, and now we've got the 3 to 5 going all the way down to 0 degrees Celsius. Two tools, they've got their pros and cons, but down at these sorts of temperatures, background radiation can be a real problem. We can do what I just described with the M390 and take an external temperature input, or alternatively, the pyrometers have an internal temperature sensor. So if we know what the ambient temperature is in the environment, we can use that as a background correction as well. Now, I mentioned the 30-to-1 field of view. That's quite an important characteristic of these pyrometers. So I wanted to describe what we mean by field of view, because typically when we just talk of field of view, we think of a very sharp-edged circle. And if we say it's 30-to-1, then there's a dot that we see everything within that circle and we see nothing outside it. That is actually a little bit simplistic. With real-world optics, real-world detectors, and even real-world objects, there's always a bit of fuzz around the edge of the field of view. And exactly how much fuzz there is very important for temperature measurement with an infrared pyrometer, and it's even more important as the wavelength gets longer. The graph on this slide shows the measurement uncertainty on the y-axis as a function of measured temperature at 3 different wavelengths, at 1 micron, at 5 microns, and at 8 to 14 microns. Basically, and that's for a 1% change in radiation intensity. So a small amount of change in intensity has a very small effect on temperature measurement if you're measuring at 1 micron. Here, 1000 Celsius, for example, it gives you an uncertainty of about 1 degree Celsius. At 5 microns, where we're working with the M3 to 5, that uncertainty is up at 6 degrees Celsius. So for our new pyrometers, the mid-wave pyrometers, our field of view, we've tightened the definition of what we mean by field of view. So for our short wavelength pyrometers, it would be the 90% energy circle. For the mid-wave pyrometers, we've tightened that to 98%. And that's because we think it's very important that we're clear about what we're measuring and we're clear about the uncertainties in the measurement. Okay, I hope that's been a useful discussion. The last pyrometer I'm going to talk about today is our SPOT TMT. It's used for tube wall metal temperatures in furnaces, particularly in furnaces in hydrocarbon applications. So it is an application-specific pyrometer. It's designed for measuring boiler tubes, reformer tubes within tube furnaces. I've listed a few of the types there, also steam crackers, cokers, platformers. Unlike the two more general purpose pyrometers that we've been talking about, this one has a 230-to-1 field of view. So it has a very narrow field of view, so you can look at small objects at a considerable distance and still get an accurate measurement. Like the 390, it works at 3.9 micron wavelength, so it successfully sees through flames, smoke, typical furnace atmospheres. Measurement range 300 to 1800 degrees Celsius, so it covers really any temperature that you'd want to measure within a tube furnace. 10 millisecond response time, very fast. Accuracy 1% Kelvin, it's got good accuracy, and it's got the background correction algorithm as well, because in a typical furnace you may have refractories that are at a high temperature and are at a higher temperature than the tubes that are carrying your reactants through the furnace. And an important feature, it's compatible with our EXSH hazardous area housing, so it can be used in hazardous areas, which will typically be found in hydrocarbon applications like reformer furnaces. Just like to draw your attention to the footnote there. This is not a general purpose pyrometer. We do not recommend it for applications other than tube furnaces. That's really down to the optical characteristics to achieve the very narrow field of view we have on the TMT. We do require it to have quite a specific mounting, and that mounting is only compatible with furnace mounts. Here's a picture of our EXSH enclosure. That's a flame-proof housing for use in hazardous areas. So it's EXD protection concept in the language of hazardous area certifications. We mount the SPOT TMT for the EXSH inside this housing. And that means it can be used in Zone 1, Zone 2, or Zone 21 and 22 if it's a dust application. It comes factory configured, so there's no need to adjust a window compensation factor if you put it in there. And the EXSH housing is extremely high specification. As I said, it's flame proof, so there's no need for purging or pressurization. It's made from 316 or 316L stainless with a sapphire window, so it's extremely tough. Certified for ATEX, IEC-EX and UK-EX hazardous areas, so it has worldwide certifications. So it really is, you can put it pretty much anywhere you need to in a hazardous area. And now I'll hand over to James because he's our expert on these steam methane reformer applications.
Thank you, Derek. Yeah, really interesting application here, especially for the SPOT TMT's very narrow field of view. In fact, world-leading field of view at that wavelength and at those temperatures. So I probably don't need to go into the very basics, but steam methane reformers produce hydrogen from a steam and methane mixture, where you're passing that gas over catalyst at temperatures of 800 C. And that's what we're targeting. We're targeting those outer tube surfaces. The temperature of that surface is critical, and the window that we remain in is critical. If we're over that window, your tubes are not going to last very long. If you're under that window, you'll have a higher level of methane slip, which is indicative of low efficiency. And so accuracy with these pyrometers is really critical. We've got probably 40 years of experience supplying Cyclops pyrometers for this application. And you should probably think initially of the SPOT TMT as a fixed Cyclops, but with a load of additional capability and actually with an improved field of view. So versus a Cyclops, you can see a narrower tube from further away. And that's really key in these applications because you want to really recreate what a fixed thermocouple might be doing on the furnace. And we can do that from outside the furnace, which should be far more reliable than a skin thermocouple, should be just as accurate, if not more accurate. And in terms of maintenance and accessibility, constructability, reliability, it's hugely advantageous because of the remote nature of the measurement. The built-in background correction function is also useful. That's important for accuracy because, as you know, when you're taking a measurement of a tube surface with a hotter background, we need to account for that that incident radiation, which we can do from either a thermocouple that's on the furnace, or we can even install an additional pyrometer that's measuring the wall, and we can have those talking to each other. So great application across loads of fired heater applications. We've actually seen this pyrometer used in reactors as well, looking at catalyst beds, and even in steel and DRI applications where you have process gas heaters. You even have steam methane reformers used for the reducing gas in shaft furnace applications in DRI production as well. So we're just learning really what the application story is on this. So this is a just an exciting sample of that. So back to you, Derek.
Okay, thanks, James. James said right at the start that you'll probably have noticed we've got a new look to our slides if you've been to any of our webinars before, and our new logo. We're producing a lot of either fresh or refreshed marketing material, an updated SPOT Plus brochure with all of these pyrometers in it, new application notes covering the topics that we've been talking about today, temperature measurement and reheat furnaces, cold rolling mill strip temperatures, hazardous area markings. And there's an industry magazine which wraps up a lot of our applications and a lot of our products on steam reformer tube wall temperature measurement. There, mouthful there. If we've whetted your interest for any of these applications, we do have quite a few demo instruments at our sales offices around the world. And really, if you want to understand what SPOT does and how effective it is, actually seeing one in operation is really the best way to do that. If you want to have a demo, contact your regional sales manager or your local sales channel. For the SPOT Plus TMT, which is generally used or is often used in hazardous areas, our recommendation for the demo is to get a hot works permit and then try it out for a few hours rather than attempting to have a rather large and unwieldy, certainly for a demo, in demo terms, EXD enclosure installed. We can offer more extended trials, but those need careful coordination because although we've got quite a few demo instruments, there are still limits and they do tend to be in high demand. Right, time to wrap up. What have we got that we think gives us an advantage here? Our full range of imagers, pyrometers, software and services, we think give us an unrivaled portfolio for temperature measurement. So it's an all-in-one ecosystem. The SPOT Plus, the new models, have been designed for reliability, something I didn't actually emphasize earlier on. All of our SPOT Plus models have sapphire windows, which are very rugged and hard. The 3 new models have been designed with no continuously moving parts. The only moving part is the focus motor, and that tends to be used once when you're setting the thing up, and it stays put after that. So there's no chopper, no, as I said, no continuously moving parts. We've got the built-in background correction, we've got the fast response, we've got the connectivity, and every SPOT pyrometer has its built-in web server, so you can access it, get the readings, get the video image remotely with no need for dedicated software. The SPOT family is now complete. We've got instruments at all of the temperature measurement points we need, all of the wavelength points where we're intending to cover. The instruments I've been talking about today, they are all available for purchase. For any of our sales channels are here, they're in the price book. With lots of features, excellent reliability, competitive specifications. Give us a call, look on the website and investigate what we can do for you. And just the bottom line there, if you have a system for M6, which is our traditional 3 to 5 micron pyrometer and all analog pyrometer, that remains available. You can still use that. We're not intending to discontinue that. I hope by this point we've triggered your interest and you've got a few questions for us. So I think Paul is going to be handling the questions.
Yeah, Paul has been reviewing the questions as they've come in and prepping me, Derek. So some very interesting questions so far. There's actually a hand raised from Adam. Unfortunately, we don't have the audio enabled. So if you want to ask your question in the Q&A tab, if you're able to, we can then address that to the crowd. The first question, and probably I'll take the first half of the answer, Derek, and hand over to you for a bit more of the technical background. So the question from Hikmat Khan is why Land recommends the 3.9 micron or micrometer wavelength for steam reformers when the error is less for 1 micrometer wavelength. Very nice, easy one to start. First of all, Hikmat, thank you. But very good question, very interesting question. It's true that typically for for higher temperatures, the shorter wavelength will give you less of an error. And that's a general rule touted in infrared physics. However, with steam methane reformers, I touched on it, the background is actually hotter than the tube. So what you'll get in some cases where there's a high delta between the tube surface and the background, actually a 3.9 micron, even though it's a longer wavelength, so lower frequency, it's actually going to give you a higher accuracy than a 1 micron. So there's a boundary at some point where the delta between the tube surface and the background becomes high enough that 3.9 micron is advantageous. And in our experience, and we've done lots of testing with this using our Gold Cup reference pyrometer, in most cases, the safer option and the more repeatable option is the 3.9 micron pyrometer. That's why we sell Cyclops 1 micron and the Cyclops 3.9 micron. So it's really up to the end user, because in some cases where there's a known low delta, like on some steam methane reformers between the tube and the background, yes, a 1 micron would be more effective. But in some cases, in like a steam cracker where you have very high background temperatures and comparatively lower tube surfaces, a 3.9 is probably more accurate. So I hope that answers that one. Derek, did you want to add any physics to that?
There's also the consideration of flames and furnace gases. So if particularly if there's any visible flames in the furnace, then the 3.9 micron is hugely advantageous, because those will completely confuse the measurement with a 1 micron pyrometer. So you have a choice, basically. You can choose either depending on the application, and yeah, there's trade-offs in terms of both the radiometric accuracy and the spectral interferences.
Very good. So we've got quite a few questions and about 8 minutes left. So I'll pick these out in no particular order. Derek, one for you. Is SPOT Pro still available and supported? Should we be using Image Pro for both spots and thermal imaging cameras?
Okay, that one is, I think, fairly easy. SPOT Pro is still supported, and it's actually what we recommend for use with SPOT. Basically, Image Pro is a very high function image processing piece of software for use with our thermal imagers, and I think we possibly overstated it when we launched the facility to take SPOT Plus data into Image Pro and process it alongside the thermal image data. But really, as we've had some experience with it now, if you're not using a thermal imager, I would not recommend using Image Pro, because it is fundamentally an image processing piece of software. SPOT Pro, on the other hand, is designed to process and display data from SPOT pyrometers up to, I think we can put a ridiculous number in, something like 50 pyrometers, but I've actually seen installations with 16, and it's by far, it's far more effective. It's also far faster at displaying data from a pyrometer than the Image Pro is. So I hope that's clear.
Okay, great, Derek. Thank you. Let's answer this one from Tien Fu. This is, does the SPOT plus temperature measurement affected by the dust concentration in a coal-fire boiler? So generally on the effect of dust particulates inside a boiler.
Dust in a boiler will have an effect. The 3.9 micron wavelength is much less affected than shorter wavelengths are. There's a basic bit of optical physics that says that you can only measure things which are comparable with or larger than the wavelength you're using. Therefore, with visible light, you'll be sensitive to particles down to about 250 nanometers, a quarter of a micron. Out at 3.9 microns, you'll be insensitive to anything smaller than about 2 to 3 microns. So the small particles you just don't see in the boiler. Larger soot particles you will, but it depends how thick the smoke is, how much dust there is. But one of the key things is to some extent to try it and have a demo.
Yeah, I think that's my takeaway from a recent trial I did on a waste incinerator where there was actually quite thick particulate. Once we trialed it in multiple locations, we did find a place where we could get good transparency in the atmosphere. So the key is, I think, is to try it. Also, you can share with us information about feedstocks and fuel stocks and furnace designs, and we'll normally be able to come up with a solution. Is it possible to record video from the SPOT camera on older SPOT models?
I don't know of a way to do that. So I think the answer is no. There may someone may surprise me in our development team and say there's a devious way of getting it done, but no, I don't know of it.
I'll come back to you on that one, Ulrich, because it may be possible through Image Pro. And why is the error given in degrees K, Derek? Question from Michael Barber. And also he's asked the status of the CSA hazardous area approvals.
Okay. Errors given in degrees Kelvin because it's simpler to express it in those terms. Percentage Kelvin. The Kelvin temperature, I'll start again. The Kelvin temperature scale starts from 0 at absolute 0, and therefore is linear. So if we express error as percentage Kelvin, that is as a percent of what we're actually measuring. If we expressed it as percent Celsius or percent Fahrenheit, that would actually be reasonably accurate up at 1000 Celsius. 1500 Fahrenheit, 2000 Fahrenheit. But as you get close to ambient temperature, the difference between 273 Kelvin and 0 Celsius means that the error calculation doesn't work easily. So that's fundamentally why it is. Converting Celsius to Kelvin is very easy. You just add 273 to your Celsius number. It's a little bit harder for Fahrenheit. And asking about the FMCSA hazardous area, we actually have hazardous area approvals for our EXSH enclosure. We have not yet released that product because we haven't had enough demand for it. We found that even in North America, the IEC EX approval is acceptable to North American customers. We do have a plan to release the North American specification, the Class Div specified versions of the enclosures, but as I say, we've just not seen enough demand that's pressed us to have to do it. If there's an application where it's absolutely needed, then we could make it available. Delivery would be quite long. It would be about 20-25 weeks, but we could do it. The typical delivery on a standard EXSH with the IEC EX approval is about 10 to 12 weeks.
Thank you, Derek. One quick question, which I'll take quickly from Adam on the continued support of the fiber optic M1. Yes, they're unaffected by this, just as the system for M6 is. So no need to worry there. A great question from Tanya Ponza on aluminium applications. Are the new SPOT Plus models interesting for aluminium applications, or would you still recommend the SPOT Plus AL, Derek?
Oh, definitely the AL. The aluminium is a very difficult material to measure because it has low emissivity, it's very shiny, and its emissivity varies with temperature. So we've put a lot of effort with this SPOT Plus AL into compensating for those difficulties. So it's always been specifically designed for that application, and it will work much better than any of these new pyrometers for aluminium applications.
Yeah, I think there may be some anode baking applications, but that's obviously more, you're not really measuring aluminium, even though it's maybe in the aluminium industry, where you could use these pyrometers. But yeah, good question, because the SPOT AL is a great product and one of the application specific pyrometers that we're very proud of. I think, Derek, we'll have to leave it there. There's a few questions unanswered. A great question from Hikmat on the comparative accuracy of a pyrometer versus a thermal imager. Hikmat, I'll reach out to you directly on that to address that, because that's a good question, probably the subject of an entirely separate webinar. So thank you for that. And thank you everybody for joining. We'll sign off here. Really appreciate you spending your time with us. I know it's a busy period of the year, so thank you for that. My computer is absolutely desperate to do an update, so I'm going to let it do that, and we'll jump off and catch up with you soon. Thanks, Derek. Thanks, everyone. See you.